Okay, so let's continue the previous class discussion. That means we are going to explain here how we can perform this test with the simulation in simulation. Okay, that means open circuit and short circuit test. How we can perform on this simulation. Okay, so let's try to see whether the connection I have explained few minutes earlier. So just try to according to that or with this help of circuit diagram, you may be connection perform. Okay. So let's try to see how we can perform this experiment simulation. So just wait 2 minutes. Okay. So this is the connection for the short circuit test, and just we try to perform this test in the simulation. Okay. So this next go for the post test. You maybe find some question here. That means how we can perform while conducting a testing on the single phase transformer. One of the students tried to measure the resistance by putting an emitter across terminal of one terminal of primary and the other to secondary. The reading obtained will be how much? So just you go through this question and practice how you can after the test perform. Okay. So some problem are given here for the calculation purpose. Okay. Transformer efficiency just calculate when you single phase transformer at unity power factor efficiency is given 98%. The total losses at this connection is how much? Okay. So you have to this practice this numerical after performing this test. Okay. Next, suppose that this one transformer operation operating in parallel will share a common load in the best possible manner, and the per unit leakage impedance are equal. Okay, this one is correct. Okay, leakage impedance are proportional to their KVA rating. Leakage impedance are equal. Per unit leakage impedance are equal. Any of the mentioned. So you have to practice solve this problem after the performance of the two test. Okay. So just try to complete this test, open circuit and short circuit test in this simulation. So you will find out this component. Now you required to connect all these things. Instrument. Okay. So you may be seen in the few minutes earlier how we can connect our according to the circuit diagram. We just try to connect this one. So this is the MCB. Okay. Power is available here. Now you just connect from this positive terminal of this MCB to the positive terminal of this auto transformer. First one. So click here and drag to this point, positive polarity of the auto transformer. Not. And similarly, just click here, negative polarity of the MCB and drag to this negative polarity of the auto transformer. So power is available at this auto transformer from this MCB. Is not. So next our concern is measurement of this voltage with the help of voltmeter. So you just maybe find out one voltmeter here. So just connect across this auto transformer parallel. So positive polarity of this voltmeter you will put here. That means click and drag to this point. Okay. And similarly, negative polarity of this voltmeter connect to the negative point of this auto transformer. Okay. And next, just measure the no load current. So with the help of emitter, so just connect one emitter. So just take the positive polarity of this emitter to this positive polarity of this auto transformer. Okay. And negative polarity from this emitter is connected where to this point of M of the wattmeter. And you may be here in the circuit diagram, L and C is common. Okay. So we sort this one. And from this L, we have to connect the LB winding of the transformer. So this one is your LP winding positive polarity. So this one is positive polarity and this one is your negative polarity. Okay. So from E to the watt of the wattmeter to this point, let's say here. Now I think his connection is over. So one voltmeter may be connected in the secondary side. That means HV side. So this positive polarity connected to the positive polarity of the voltmeter, and this negative polarity of the winding connected to this negative polarity of the voltmeter. Okay. So I think you may verify this connection. Just check it. Okay. So if you click on this check connection, then you will find out your either connection is correct or not. Okay. And you carefully connect all the wire and instrument according to the circuit diagram. You know? So just click on the check connection. If your connection is correct, then it will be shown on the screen. Okay, so I think it is correct. Please complete your connection. Something we are missing here. So just to verify these things. Here we are missing something. Okay. Yeah, did you find the connection from the this point to this point is missing? So just try to connect this negative polarity of the LV winding to the auto transformer. So from this point to connect the negative polarity of the auto transformer. Okay. Now I think your connection is completed. So if you just again check it, if your connection is complete, then it will be so on the screen. Click here on the check connection. If I click here, yeah, you will find out on the screen. That means your connection is correct. Okay. Now you can proceed for power supply given to the experiment. So if you click on this MCB, then power is on. Okay. So now next what you will do here, that means click on the auto transformer so that your auto transformer supply given to the winding. So just click here. Yeah. You will find this movement of the auto transformer. So rated voltage indicated on this voltmeter. Okay. And during the no load test, current whatever is drawn by from the supply, that will be indicated through this emitter, and whatever the power consumed, that will be indicated by the help of wattmeter. Okay. So may not be directly measure from the contact view. So you just click here, add to the table. Then whatever the reading indicated here, that will be shown on the table directly. So just click here. That means yeah. So I click here. Then we got the value of open circuit test measuring instrument, that means watt meter reading 50 watt, and no load current is your 0.9 ampere, and voltage is your 230 volt. Okay, so this is all about the open circuit test. You may be carefully practice on the virtual lab, so connection will be remembered in your mind. Okay, and next we just go for the short circuit similar way. Okay, yeah, for this short circuit test. So again, same things you have to follow here. That means only you have to concern about the connection of the measuring instrument towards the SV side and LV side to sort it. Okay. So start from the MCB. Okay. So the positive terminal of this MCB is connected to the auto transformer positive terminal. So from this point to this point. Okay. And from the negative polarity of the MCB is connected to the auto transformer negative polarity. And similarly, for the measurement of this voltage, you require to connect one voltmeter in parallel. So just positive polarity of this voltmeter is connected to the positive polarity of this auto transformer, and negative polarity of this voltmeter is connected to the again negative polarity of the auto transformer. You know. Now for the measurement of current during the short circuit test, we require one emitter connected connection. So just take the positive polarity of this emitter to this positive polarity of the auto transformer, and from this negative polarity of the emitter given to the wattmeter M terminal is not from this negative polarity of emitter to the M. And as you know that the L and C is your common, so just sort this L and C, and this L is go to the where the this one is considered here HV side. Okay, so P1, this one is your positive and this one is your negative winding of negative polarity of this HV winding. Okay, and this one is your positive and this one is your negative of this LV winding. So just solve this one. Yeah. And next, from this V polarity terminal of the wattmeter to connect the negative polarity of this HV winding. Okay, and next, just connect from this point to this point. That means the negative polarity of the transformer to the negative polarity of this auto transformer. So you maybe check it. Your connection, I think, is correct. Okay. So just click on the connection check. So check the connection either is correct or wrong. So just click on your correct your connection. Okay. So you can start your screen. Just click on this MCB. So power supply even on. Okay. And if you click on this button, that means auto transformer. It's moving handle of the auto transformer. So yeah, supply going to be. So this current is your rated current, and during this test, what is the voltage required, that is indicated by this voltmeter, and whatever the power consumed during the short circuit test, that will be indicated by this short circuit, that means wattmeter. Okay. So during the short circuit test, we just consider the ohmic losses and neglect the core losses. Is it not? So if you click on the add to table, then whatever the reading showing here in the various instruments like the voltmeter, ammeter, and wattmeter, that will be noted in the form of table. Okay. So that is better to just put here, click button. Okay. Yeah. So this is your 37.5 watt power consumed during the short circuit test and 4.5 ampere current during the short circuit test, and voltage required is 11 volt. Okay. So from this table, you can just calculate the value of resistance and reactance value referred to the high voltage side. So I think we already explained few minutes earlier. So your calculation can be completed just from this table. Okay. So you have power consumed during the short circuit test, that is 37.5 4.5 ampere current at 11 volt. So how we can find the resistance value? Means how we can find the resistance value? Just tell me. That means power divided by I square R. You know, power divided by I square R. So 37.5 divided by 4.5 whole square. You know. So you will get the value of equivalent resistance referred to the high voltage side. So if you just get a 37, how much? 37.5 divided by 37.5 divided by 4.5 whole square. So this value is how much? 4.5 into 4.5. Just for calculate 25, 25, 22. So 5202. So 20.25. 4.5 is whole square is 22.25. So 37.5 by 20.25. I think you will get how much value if you divide 37.5 by 20.25. Then you will get value how much. So that you can calculate. And next parameter, that means the impedance value. On the equivalent impedance value on the high voltage side, that means how much? Voltage or short circuit voltage by current short circuit. So voltage short circuit you already obtained from the voltmeter, that means 11 by current is for how much? 4.5. So just divide this 11 by 4.5, that you will get the value of impedance value. Is it not? So this impedance value and resistance just okay. So you already find the resistance value and impedance value. That means 11 by 4.5. So just you calculate the value how much 11 divided by 4.5. That means 145. So just 2 times. That means 90. So 20.44. So I think almost 2.4. You know. So 2.44 is your impedance value on equivalent impedance value on the high voltage side. Similarly, you can calculate the resistance value. You calculate the resistance value. That means how much? 37.5 divided by 20.25. So how much? 37, 50 divided by 20, 25. So 1 times, that means 20, 25, 5, 4 to 2, and here you will get how much? That means 7, and this one is your 1. Okay, so point 1.7. So I think almost you will get the value of R resistance equivalent, that means resistance equivalent equal to 1.7, and impedance value is your 2.44. So if you put the value on this formula x equivalent, you will get the value of x equivalent. That means impedance square minus reactance square, you know. So that means the square root of 2.44 whole square minus 1.7 whole square, 1.7 whole square. Okay, if you solve, you will get the value of equivalent reactance value. Okay, or otherwise, if you directly submit here, that means have submit the value, you note down and just calculate simply all the parameters during the short circuit test required. That means the resistance value and reactance value refer to the high voltage side. Okay, otherwise if you put here directly submit, then you will get the parameters of the transformer. That means total parameters of the equivalent circuit parameters. Okay, that means core loss, resistance, magnetizing reactance, and R1 X1 and R2 X2. Okay, so if you click here, okay, then you will get the complete parameter of the equivalent circuit. So I think this one is your core loss resistance. That means 11 by 50, and this is your magnetizing reactance. That means 287.5 ohm, and this one is your R1 resistance and X1. That means on the high voltage side, and this low voltage side resistance refer to the primary side. Okay, that is high voltage side. So this resistance you may be transferred towards the low voltage side also. Okay, so how you can calculate this value? That means core loss resistance value RC. How can you calculate this one from the open circuit? Have you remember? That means how much? V1, that means 230 volt, I think, divided by exciting current into cos phi 0. So how much the value of cos phi 0 during the test? So V1 is your 230 volt, IE is your how much? 0.9. If you observe the previous reading during the open circuit test. Okay, so no load current is your 0.9, and uh, power rating is I think 50 watt, equals 50 watt. So you maybe calculate the value of core loss resistance. That means 230 divided by 230. First you calculate the value of cos phi 0. So cos phi 0 is equal to how much? That means power divided by V1 IE, no load current. That means 50 divided by 230 into 0.9. So 0 0 is cancelled from numerator and denominator. And now 5 divided by 9 into 3, 27, and 9 into 2, 18, or 2, 20. So 5 divided by 20.7 is your cos phi 0. So from this, you may calculate the value of so 5 divided by 20.7, that is equal to how much? That is inverter 20 divided by, sorry, 5 divided by 20.7. So 0.24. You get the value of how much? Cos phi 0 equal to how much? 0.24. 0.24. So from this cos phi 0, you will maybe also get the value of sin phi 0 equal to square root of 1 minus 0.24 whole square. Okay. So if you put here the value of 1 minus 24 into 24, how much? 576. So 0.0576. get the value from this one. So you may find out this sine phi 0. Okay. So RC equal to, that means 230 divided by no load current into cos phi 0. So no load current is your 0.9 into 0.24. So from this you will get the value of almost 1150 ohm. Okay. And similarly, XM equal to magnetizing reactance equal to, you will get how much? That means 230 divided by 0.9 into sine phi 0. Sine phi 0 is equal to nothing but the square root of 1 minus 0.0576. Okay. So if you solve this value, numerical value 230 divided by 0.9 into a square root of 1 minus 0.057, then you will get almost the value of 287.5 ohm. Okay. And how you calculate this parameter? That means R1, X1, and R2 dash and X2 dash. So just you take the data of the short circuit test. That means how much power consumption during the short circuit test. You remember during the short circuit test, power consumption was power consumption was how much? 37.5, I think, and voltage rating was 11 volt, and current rating short circuit is 4.5 ampere. So from this data, you can calculate the value of R1 and X1 and R2 dash and X2 dash. That means equivalent resistance equal to R1 equal to R2 equal to 1 by R equivalent 1 by 2 R equivalent on the HV side. Okay. So you will practice this test for the connection and overview all these things. So maybe practice suppose one more time. See if you want to do here in your own hand, then you can do. Okay. So this is the complete equivalent circuit diagram with the parameters. Okay. Okay, that means core loss resistance. This is your setting current or no load current. Okay, is two part, consist of two part. One is known as the core loss resistance, core loss component current, and another is magnetizing component of current. That means IM. Okay, so you may be indicate here the IC and IM. Okay, so you will practice these things, otherwise you will not get the value in proper manner. Okay, so just you may be uh, just suppose that if you reset this one. Okay, so just go through this one. That means so from here short circuit. Okay, so you may be reset all these things. Okay. So again go back to the main diagram. Okay. Go to the simulation and just try to practice for the main open circuit test. Okay. So just connect from this point, that means a positive to this positive polarity, this negative to this negative polarity, and this voltmeter is connected in parallel, means from this point to this point, and from this negative polarity of the point to this point, and this emitter just connect here from positive to this positive terminal of the auto transformer. Okay, and From this negative polarity of this emitter, go to the internal of the wattmeter, you know, and L and C just sort. So just to put here the L and C. And from this L point, just to go to the LV winding of the positive polarity. So just this is your positive polarity of the LV winding. And this one P2 is your negative polarity of the LV winding. So this one is connected from the P2 to V. Okay. And next, just from this negative polarity of the LV winding is connected to the negative polarity of the auto transformer. Okay. So if your connection is correct, then you maybe check on if click this check connection. Okay. So just click. I think this connection is correct. Okay. So just if you click on this button, okay. Just if you click on this button, that means you will get the same things as is previous shown in the diagram. So just click here. So connection is not completed. Please complete the connection. Your connection is not completed. So check it where you have to on this one. Your connection is not completed. If you click here, then on the screen you may find out one message that is reflected on your screen, that is please complete the connection. So you just go on the connection part and you will find out this voltmeter not connected towards the HV. So you just connect, this is your positive polarity. So this positive polarity to this positive polarity of the voltmeter, and from this negative polarity to this negative polarity of this voltmeter. So now I think your connection is correct. So again it check. So yeah, now your connection is correct. Correct your connection. Okay. So you may be proceed for the experiment purpose. Now so power just supply on. If you click on this button, that means MCB. Okay. So you click on, yeah, the power is your on. Okay. So if you click on the auto transformer, then your power is supply given to the transformer in no load. So just click here. Okay. So you may find out here the reflection of the auto transformer. So all the instrument reading is showing here some deflection. That means indicated some voltage value, some current value, and some wattmeter. Okay, but you cannot read out because the scale is not mentioned here. So this one is your automatic voltmeter and emitter and wattmeter. So if you click on this point, that means add to table, then you will get the voltmeter, emitter, and wattmeter reading here in the table form, whatever at this point. Okay, whatever at this point. Okay. That means wattmeter reading here, no load current, emitter reading here, and no load voltage, rated low voltage, you may be noted here. So just click here on this button, that means add to table. So all the parameters you may be find out in the table form. Okay. So can you click here? So just add to click here. Yeah. So you will get the value of power consumption during the no load test. That means 50 watt and no load current, that means 0.9 ampere and 230 volt. So either you maybe take the reading note down, okay, and complete the calculation part. That means RC and XM, magnetizing reactance, and core loss resistance value with the help of the three data, that is wattmeter, ammeter, and voltmeter. Okay. So how you can calculate? We already explained some concept here. Okay. So you maybe go through the calculation part, that doesn't matter, and complete the process. Otherwise, if you go through the simulation purpose for the next, that is short circuit test, so you can note down this data and click here. That means short circuit test. So you will move to short circuit part. Okay. So just you note down all these three data and just click here. So you are able to get in the short circuit test part. So just click here. Yeah. So now you can just connect all the instrument in the same manner. So just here some part we find out. That means from the positive polarity of this MCB point to the positive polarity of this auto transformer, and negative polarity from this MCB to the negative polarity of this auto transformer. And for the measurement of this voltage, you may connect this voltmeter, that is positive to positive, not, and from the negative to negative. Is it okay? And from this point to the emitter positive terminal, that means here, and negative terminal of this emitter is connected to the M terminal of the wattmeter. Okay, and L and C you may be just connect here, and from this L point is go to the positive polarity of the HV winding. So this one is your HV, and negative polarity from the HV winding to this P terminal of the wattmeter. Okay, and just this one is short the LV winding. So just short this two terminal, just either maybe just connect these 2 points. Yeah, so I think it's completed now. So if your connection is completed, then you just go through the check of the connection point and click on that point. So you are able to get the data here. Okay, so you just maybe check the whether connection is correct or not. Okay, please complete the connection. Your connection is not completed. So you again go through the connection part and check it. So I think from this point is connected, voltmeter is connected, and from this point to emitter is connected, and emitter negative point is connected to the M point of the point of the wattmeter, and C and AB short is correct. And from this L to LV winding of the positive terminal, and from this to this, and LV winding sorted. Okay, and this one is your HV side. Okay, P1 and P2 winding is your HV winding, and S1 S2 is your LV winding. So LV winding is sorted here, but again, yeah, go from this point to the path complete here. So negative polarity of the HV winding to the auto transformer. So you will go for this part. That means this one to this one. Okay. So now I think it is correct. So again, go to this check connection part. So just you maybe click here. So now correct your connection. Okay. So and now supply given to the MCB, just put on the click button here. Okay. So just click. Yeah, power is on the MCB. And if you click on this button, that means of the auto transformer moving point, then your supply is given to the transformer. Okay. During the short circuit test. So just put here click button. Okay, and again same thing follow here. That means whatever the deflection shown here, the voltmeter and emitter, maybe note down in the table form. That means maybe table is formed here. That means short circuit power, short circuit current, and short circuit voltage. Okay, so if you click on the add button, then you will get the data. I think okay. So this is your data for the short circuit test. And just to submit, then it will be all around. Okay, so just we stop here. In the next class, we will discuss everything.